Okay, let's have a look at the cosine curve. Now, this is slightly different to the sine curve in that the sine curve, we start at what we call the no motion position. In other words, if it's a loudspeaker, it would be the point where the loudspeaker is at rest with no voltage being applied, which would be along this line here. With the cosine, we actually just start at 0 degrees, which is over here. So what we're doing here is we're finding the times when and there will always be two times within 360 degrees. In other words, we're looking at the degrees from 0 through to the full 360 over this end here. And what we're trying to do is we're trying to find, and when the question's asked like this, what it means is how far through its cycle has x passed in order for the amplitude to be 0.65. So what this one here is saying is, well, we can actually find that out. We can actually say if it's 0.65, where's 0.65? Well, 0.6 is here, 0.65 is here-ish, around there, yeah? And if we were to go down here, we could say, well, what is this here? What's that point there? And we would find out that that, in fact, is, and we can work it out on the calculator, here it is, we're going to find the arc cosine. In fact, I'll do it over here first. So I'll go the cosine of x is equal to 0.65. And we want to find the arc cosine of that. So we go, so x is equal to the arc cosine of 0.65. There it is. And that is equal to, so we're going to go arc cosine of 0.65 is 49, and I'm going to call that 0.5. So here it is, 49.5. There we go, 49.5 degrees. So that means that this point here at 0.65, there it is, there's 0.5, 0.6, 0.7, 0.8, 0.9, 1. So 0.65 is there, 0.65 is there. There it is, 0.65. And this here, this angle here, this number of degrees through which it has passed, is passed through 49.5 degrees of its cycle. This is going to be 49.5 and then degrees. There it is. All right. Now, of course, it doesn't just stop there. It actually keeps going. And this is what this does not tell us. When you get the calculator to do it, it only gives you one value. Of course, you've got to come up with the other values within the 360 degree wave. And of course, the other one is 310. Well, how does that happen? We're always subtracting it from this point here. This is our, if you like, the 0 position. So whenever it's in this position here, so here it is over here, and it's in this position again over here. Look at that. So this is in fact 360. So there's my 360 degrees. And if I was to, of course, to then take 0 and add on the 49.5, I would end up with my 6.65. And you can show that on the calculator because you can do the opposite. You can say, what's the cosine of 49.5? Here it is, cosine of 49.5, and we end up with 0.6, effectively 0.65. The same is true at the other end. So if we had our 360 and we subtracted now that 49.5, so if I took my 360, subtracted 49.5, I would find the other value. And that other value, by the way, we can see, because we could just follow this line along. In fact, I could actually be a little bit smart here and actually use a ruler, which would seem pretty obvious, wouldn't it? So here we go, there's 0.65. It's going to be along there somewhere. Just draw this all the way along. Now, I know this is off the screen a bit, but if I go here, you kind of see where it ends up. So it's going to be about here. Now, I haven't done this very accurately, but it's about there, yeah? Now, what is this value here? Well, the value there is, in fact, 310.5 degrees. And of course, you can calculate that the same way. You could say, well, if we had 360 and we subtracted the 49.5, that's where we'd end up. So let's try that now. We'll go 360 minus 49.5 degrees, of course, is equal to, and I'll just have a look at that now. So I've got 360, I've got my 360. Oh, is that focus? Go to focus. Ah, there you go. 360 minus the 49.5, and we end up with 310.5. So there it is, 310.5 degrees. And that's how we find the other value. So within, in other words, 360 degrees, which is what this is, we're looking for the number of times it reaches that value. Well, let's have a look at another one. So let's imagine it was, in fact, ooh, crikey, what's a good one to do? What about the last one there? That looks a bit of an evil one. It's got quite a difficult value actually to find. Well, if there's 1, and this is 0.74, so that's 0.567, which is about 0.75, and it's about halfway in between, actually. Now, I could take my ruler and actually rule that straight away, so I'm going to do that. So there's my value there. I'm just going to rule straight through and see where this ends up. So I'll just ignore everything. I'll draw straight through it. I probably shouldn't, but there it is. So there's a value there, and you can see there's another value there. And the question is, whenever you see this, is it's asking how far through its cycle, and these are the words to remember, how far through its cycle has the wave passed in order for the amplitude to be negative 0.136, or in this case, wait, sorry, what am I doing? I'm doing this one. In order to be negative 0.7486. And I mean, you can't do it very accurately there, but you get the idea. So let's have a look at what that would be. In fact, we can see the answer here, and let's see if that corresponds to what we think it is, 138.5 and 221.5. So that is about, so what they're saying is that's 138.5. That's that one there, yeah? This one over here, what we're saying is that should be 221.5. Of course, we can calculate that. Let's go ahead and do that. So let's go cos x is negative 0.7486. And what say it is, so x therefore, in other words, how far through this has passed, that cycle has passed, in order for the value, the amplitude to be that, it's going to be the arc cos of negative 0.7486. Pop that in brackets. Don't need to, but because the calculator doesn't mind, but I think for your teachers, they probably would mind. So let's go ahead and find that now. So we've got the arc cos, there it is, of negative 0.7486. And we get 138 points, and I'm going to call that 0.5, yeah, rounding up. So 138.5 degrees. Notice there's no space in between the 5 and the degree when we use degrees as a unit, whereas if it was meters or kilograms or whatever, we would have a space there. So 138, so this we're saying is in fact 138.5, but if we want to find this one, we're now coming from the other side. We're taking 360, we're subtracting the 138.5, and we should end up at 221. Let's see if that works. So we've got our 360, we're subtracting this thing here, 138.5. Let's see how that works out. So I've got 360, subtracting 138.5, and we end up with 221.5. It's 221.5 degrees, and that's exactly what we find here. So folks, that is how we find the other value for the amount of how far through the cycle has passed in order to be a certain amplitude. Hope that makes sense.